In this set of notes, we're going to look at two sections combined. We're going to be looking at sections 12.2 and 12.3, where we will integrate integrals over general regions. Basically, what's going to happen here is we're going to be looking at iterated integrals, integrals in both x and y, over non-rectangular regions. What's going to happen here is our limits of integration will no longer be completely constant. So for single integrals, the region we integrate over is always an interval. But for double integrals, we want to be able to integrate over more general shapes than the rectangles we saw last class. So I'm going to illustrate the process by taking a look at an example or two. What we're going to find are these regions are no longer rectangles. Now here's my example. I'd like to find the mass of a plate bounded by y equals 0, y equals x, and x equals 1 if, and what this is the density, if the density at xy is equal to e to the x plus y. The fact that we need to know in order to be able to do this is the integral of the density over the area, and again I'm going to use the region notation we used last time, will give us the mass. So the integral of the density is going to give us the mass. So to do this, before I get going, I'm going to draw a picture of the plate. And this will be important for us. We will want to draw a picture. So here's my xy axes. There's x, there's y. It's bounded by y equals 0. So remember, y equals 0 is the x-axis. Y equals x, there's the line y equals x, and x equals 1, and that's a vertical line. So this right here is the region that we're integrating over. So notice as we do the integration, we end up having a triangular region. So to set up this integration, what we do is we're going to have a double integral. And I'm going to be integrating e to the x plus y. And now I have to make a decision whether I want to do dy dx or dx dy. Now, for reasons that'll be a little more interesting to us after, I'm going to actually do dy dx, and I'll explain why as we get going. To do this now, our outer integral will always be constants. So our outer integral is dx. So we look at the region that we used, and we look and we see what's the smallest x we use on that region. And in this case, the smallest x is x equals 0. What's the largest x we use? Well, the largest x we use, if we remember when we graphed, was x equals 1. So I'm going to go from 0 to 1 on the outer integral. Now I can't use numbers on the inside. If I use completely numbers, what's going to happen is I get a rectangular region. So I do need the y's, and then to do the y's I need to go bottom to top. Well, the bottom is the x-axis, and so what's going to happen is on the bottom we'll be integrating from y equals 0. But then on the top, notice that varies based upon where we are on the line. We're going to integrate up to that function, and so we're going to integrate up to y equals x. So if I clean this up a little bit, the outer integral will be 0 to 1, the inner integral will be 0 to x, and I'll have e to the xy, which I'm going to actually write as e to the x, e to the y. It'll make my integration a little bit easier, and so I'm just using one of those rules from algebra. So now, if I want to integrate this, I just do the work as we would have before. Integrate with respect to y first. So e to the x will act as a constant. Integral of e to the y is just e to the y from 0 to x. Substitute in. So that's going to give me e to the x, and when I substitute in, that's going to give me e to the x minus e to the 0. Right? I plugged in the upper and the lower integrals. Dx, 0 to 1. And now if I neaten this up just a little bit, this is going to give me e to the 2x minus, and remember e to the 0 is 1, so it's going to give me minus e to the x dx. Now I do the integration here. Integral of e to the 2x is e to the 2x divided by 2. Integral of e to the x is e to the x. And I'll do that from 0 to 1. And if I integrate, that would give me e to the second when I substitute in the numbers divided by 2 minus e to the first. Subtract, when I substitute in 0, that's e to the 0 over 2 minus e to the 0. And if I do that math, that's e squared over 2 minus e. And then here I'm going to have minus 1/2 plus 1. Double negative will give me a plus 1. And that's going to end up giving me e squared over 2 minus e plus 1/2. And there's a variety of ways I could actually write the final answer. That's the exact answer. That is what I would expect you to be able to do.